So welcome back for part 2 of Unit 3A, Day 3. We're going to talk about quickly now both what we call the remainder theorem and the factor theorem. So we want to be able to solve functions using both of those theorems, whether we're going to evaluate the function with the remainder theorem or if we're actually going to find if something is a factor or not using what we call the factor theorem. So first and foremost, the remainder theorem. When we talk about the remainder theorem is we're trying to find the solution to a function, and the remainder theorem is one way that we can find the solution to a function. So mathematically, the remainder theorem says when we divide a polynomial f of x by f minus k, the remainder is k. And we know that. So we talked about that a little bit before. So what we're going to do today is we're going to work on finding the remainder. This kind of moved over on me when I copied it, it looks like. See if I can cut this and move this over a little bit. There it is. So what we're going to do today then is we're going to work on finding the remainder when f of x is divided by x minus k. So it's a lot of what we did really in part 1. It's still going to be synthetic division. The only difference is now what's going to go inside the box because they're giving us, or we're going to be given the k value. So for example, we're going to be given the function, let's say we're given the function f of x is equal to 4x cubed minus 11x squared minus 5x plus 22. So we're given this, but now we're going to be given that our x value, or our k value, is equal to -1. So they're telling us that our divisor, we've already got it. Okay, so in this case, our divisor would have been x plus 1. As if you think about this, this is equal to 0, so then x is equal to -1, and it's kind of the reason that all this works. So we're going to put instead of switching the sign kind of how we did yesterday, or in part 1, we're just going to put a -1 inside of this piece of it. And we're going to drop down our 4, again, making sure that we go in order from the highest exponent all the way out to the constant. We're going to draw our line. We're going to bring down the 4, take -1 times 4 to get -4. That gives us -15. -1 times -15 is 15. That gives us 10. -5 plus 15 is 10. This gives us -10. And then this gives us 12. So our remainder here is just 12, and that's what we're looking for today. That's all we're looking for in this part, is we're just looking for what this remainder is. Now, essentially what this remainder theorem tells us then is that if I want to evaluate this function at f of -1, if I evaluate this function at f of -1, my answer is going to be 12. That's what the remainder theorem does. So if I plugged the -1, and we've done this kind of substitution before, if I plug this into my calculator, if I plugged all of that into my calculator, this end result is actually going to be 12 as well. And this is called the remainder theorem. We find that remainder theorem, and that remainder theorem allows us to really evaluate, in this case, we could evaluate f of -1. Again, you're just going to be asked to find the remainder theorem today, and just understand that that's what the remainder for this does. And add another plate. Let's look at another example of the remainder theorem. So now in this one, we're going to go f of x is equal to x to the 4th plus 9x cubed plus 12x squared minus 4x. And we're going to evaluate this one at k is equal to 1. So again, we're going to be asked to find the remainder. Okay, so since we're finding the remainder inside of our box is exactly what we see. We bring down the fourth, x to the third, x squared, x. Notice there's no constant in this one, but I'm going to put it there. Okay, we need to go x to the fourth, x to the third, x squared, x, and then that constant needs to be there as well. So if that constant is left off, make sure you put that there. So we'll get 1. 1 times 1 is 1. 9 plus 1 is 10. 1 times 10 is 10. 12 plus 10 is 22. 1 times 22 is 22. Negative 4 plus 18 is 18. And you'll notice it's 18 here and 18 here, and it just worked out that way this time because our answer was 1. But there is our remainder. And again, I got to emphasize this again. If the constant isn't there, make sure you put that constant there. Okay, go ahead and try one of these on your own. We're going to find the remainder again. Let's go with f of x is equal to 5x cubed minus 3x plus 5. And we're going to find this one for, let's do 1 again. Let's do k is equal to 1. Okay, so we're going to put a 1 in there. So we've got 5. Remember, notice we start at x to the third. X squared isn't there, so I got to fill in x squared with a 0. So x is negative 3. Our constant is 5. Siri's talking to me in the background. So I bring down that 5. So take that 5. 1 times 5 is 5. 0 plus 5 is 5. 1 times 5 is 5. Negative 3 plus 5 is 2. 1 times 2 is 2. And we get a remainder of 7. So then again, if we wanted to evaluate f of 1, our answer would be 7. Again, we're just looking for that remainder thing. Now, what would happen if that remainder ended up being 0? We haven't had anywhere that remainder was 0, but what happens when that remainder becomes 0 is then we have what's called the factor theorem. What the factor theorem essentially says is that if your remainder is equal to 0, then that x minus k is a factor of your f of x. Okay, so we can use the factor theorem again, and this is kind of where we're going in long term. Long term, we want to be able to graph these things and factor them. So we can use synthetic division to figure out if one of the essentially zeros or roots that we call them is actually a factor of this. So if we look at the example we have here, it says determine whether x minus 1 is a factor of x cubed minus 4x squared minus 3x plus 6. If so, write the polynomial as a product of two factors. And then when we've really done this already. Okay, this is just, I just threw my pen across the floor. This is just division. Okay, so this is just division. Now my divisor is going to be this x minus 1. So because I have x minus 1 and it's my divisor, this is different than the ones we just got done doing. So this is back to the division. So this is, we got to figure out the 0 of this. So x is equal to 1. So it's going to be a 1 inside of the box here. It's different than the remainder theorem. In the remainder theorem, you're given the 0. That's what this piece is. This is called the 0 or the root. In the remainder theorem, you're given that root. In here, you're not given that root. So we got to find it. So it's just whatever makes our divisor 0. So again, now we just look at our polynomial, 1, negative 4, negative 3, and 6. Sorry, we draw our line, bring down the 1. We should be getting good at this by now. 1 times 1 is 1. That's negative 3. that's negative 3, that's negative 6, that's negative 6, and it's 0. So my remainder is 0. So because my remainder is 0, that means that x minus 1 is one of my factors. Now, we've worked on factoring a lot. We've factored trinomials, we've factored by the box method, we've done all of those things, and we've always had two binomials that were together. Well, now we're going to have a binomial. So when it says write the polynomial as a product of two factors, well, x minus 1, that's my first factor. My second factor is just taking our division like we did when we did dividing. This just became x, and we started with x cubed. So this is going to be x squared minus 3x minus 6. But now we don't have a remainder to put on it like we did when we were doing the division problems. So this is what this turns out to. If the remainder is 0, what it's going to look like kind of in factored form. We may be able to factor this at some point, but not today. You're just going to write it as two factors today, and you're going to call this good. And remember, this only works when this is 0. It only works when this is 0. Let's look at another example. We're going to determine whether 8 is a 0. So when it says 8 is a 0, that's essentially saying, is x minus 8 a factor of this? Okay. Got to watch the wording a little bit. This tells us it's a 0, so it's already giving us what's inside of the box. Really what it's asking is x minus 8 then a factor of it? Okay, so we can write our numbers down. So we've got x to the third is 1. X squared isn't there, so I got to put a 0, a 3, and a negative 4. I drop down the 1. That's an 8. That's an 8. Ooh, that's 64. At this point, I can tell it's not going to work. I mean, this is, 67. This is a really big number, making this a really big number. That big number is not 0. So since it's not 0, x minus 8 is not a factor, because it's not 0. And if you get to a point where you can see that it's not going to happen, you're good to go. You don't really need to do any more than that at that point. Okay. I'm going to have you try one more. Again, I'll have you press pause. So let's go with f of x is equal to x squared plus 4x minus 5. And I want to know, is x plus 5 a factor? So inside of our box, we're going to put negative 5. X plus 5 equals 0, so x is equal to negative 5. 1, 4, and negative 5. This looks like it's going to be good. We got 1. We've got a 1. We've got a negative 5. We've got a negative 1. We've got a 5. We got a 0. So is it a 0? Is it a factor? Yep, it's a factor because we got 0. If you're asked to write it as a product, we started with x squared, so then this is just x minus 1. Only do that if they ask you. If it just says determine if it's a factor, that's just a yes or no question, and you determine it with that. Okay, so that's taking care of the second part of it. This also takes care of the lesson for day 3.2 or whatever I called it. Have a good one.